the volume of each space figure. So we have a cube with 3-inch edges, and we have a rectangular prism that's 3 by 5 by 9. Chris? Yes, you can. So this is what I'm going to pause it. 3-inch edges B. Jada? 27. The volume for a cube, you can either do rectangular prism, length times width times height, or you can do big B times H. Doesn't matter. Big B would be the area of the square, which is 3 times 3, times the height, which is also 3. So 3 times 3 times 3 is 27. And that would be cubic inches. How about a 3 by 5 by 9 rectangular prism? Yeah. 135. Length times width times height, and that would be meters cubed. Remember, length times width times height only works if it's a rectangular prism. Would not work for a triangular prism or a pentagonal prism. But it does work for a rectangular prism, and a cube is technically a rectangular prism. Because remember, a square is also a rectangle. Okay, so today what we're looking at are similar solids. So we've done similar figures, like similar pentagons, similar hexagons. They're the same shape, different size. Today we'll have similar solids. So same thing, same shape, different size. So the definition of similar solids is that they have the same shape. So on your homework, if they give you a pyramid and a prism and ask you if they're similar, the answer is no, they're not the same shape. Okay. All those corresponding parts, if you remember, does anyone remember the word we say for similar? Starts with a P. Proportional. What was that, chapter 7? Similar figures. We said proportional like a million times. So they create the same similarity ratio. Now we did look at this similarity ratio. We did the ratio of perimeters and the ratio of areas back in chapter 10. And some of you really struggled on these problems. So today we're going to add in volume. So make sure you're paying close attention because a lot of you struggled with this. The similarity ratio is just the corresponding parts as a fraction or as a ratio. Remember, we always reduce when possible. The ratio of the areas, does anyone remember what that was? A squared over B squared. I didn't put the perimeter on here because there isn't a perimeter of a 3D shape. Now, when you see area for 3D shapes, this is going to be surface area and lateral area. It's not just area, surface area or lateral area. Anyone want to take a guess as to what the ratio of the volumes would be? Savannah? A cubed over B cubed. So depending on which one I give you, you'll have to find other ones and then possibly write a proportion. So to go from similarity to area, what would I have to do to the ratio? Other way around. Just square. Square the top and the bottom. If you're going from the similarity ratio to the volume ratio, you would cube the top and the bottom. If we were going backwards from volume back to similarity, what would I have to do? Cube root the numerator and the denominator. And of course, going from area back, we would square root. Now, what if I wanted you to go from volume to area? Perfect. You will cube root it first to get the similarity ratio, then you'll square it to get the area ratio. So sometimes you'll have to do two things to get to what you want. All right, first three, are they similar? Yes or no? So first look at their shape. Sure, they're both rectangular prisms. Check that all of their corresponding parts are proportional. So 3/6, that's 1/2. 3/6, that's 1/2. 2/4, that's also 1/2. So this would be yes. The similarity ratio is 1 to 2, or you can put it as ratio instead of a fraction, but make sure you do reduce it. Now the next one, we have two cylinders, so they are the same shape. Do we think that these are similar? Yes. What is their similarity ratio? 6/5. So this would be 6/5 for my radius, and then 12/10, which when I reduce that by a factor of 2, does give me 6/5. Remember that a cylinder only has 2 dimensions, a radius and a height. So this would be S, 6/5. And how about our last one? Another pair of rectangular prisms, Evelyn? No. We see 2/3, but then we see 3/6. So we have 2/3, we have 3/6, and we also have another 2/3. So even though these two match, since the third one does not match, this would be no. Doesn't say to explain, but if we were explaining, we would just say that the corresponding sides are not proportional. All right, below we have some volume and surface area ratios given. They want us to work back to find the similarity ratio. So a lot of you would benefit from, and you don't have to do this, but since a lot of you struggled on the chapter 10 quiz, you might want to take my advice on these problems. You might just want to set up the little chart every time. So this one gives me the volumes. And it wants me to get back to my similarity. So what will I have to do to get back to the similarity? Cube root. What? It should be a perfect cube. It is.
1331. It's 36.482.
Did you do the square root or the cube root?
Yes.
Cube root of 729 is 9. And the cube root of 1,331 is 11. I bet you put 1311 or something. So that's it. 9/11ths. Back we're going to get much harder. But right now just work backwards to your... Now, if this were not a perfect cube, then you may have to reduce the fraction before cube rooting. That's something that sometimes happens. The next one, they give us surface areas. So we're given our 144 over our 324. How do I get back to the similarity ratio? Square root. Square root of 144 is 12. The square root of 324 is 18. And then we can reduce this to be what? 2/3. Divide by 6. 2/3. Now on the back we're going to make it harder. And these are the problems that you guys struggled with on, I think it was the 10-1 to 10-4 quiz, if I remember. It's like the back page, and some of you got like minus a whole lot of points because of these problems. So, using similarity ratios to find a volume or a surface area. The first thing you always want to do is to find the similarity ratio. Just like we did in the last two examples. So you may have to square root or cube root to get back to your A over B. Then find the new ratio that you want. And that's going to be different in every problem, whether they want you to find the volume or they want you to find the area. Once you have the ratio of what you're asked to find, then you can write a proportion and solve. How do we solve proportions? Like cross multiply. A lot of you on your Chapter 10 quiz just went straight to step 3, wrote a proportion, cross multiplied, and solved, and you were 100% wrong. Okay, problems will not be that simple in the back. You have to do some work. So they give us the lateral area of two similar paint cans, which would be cylinders. Here they are. And if you want, you can draw them. So we see that the lateral area of this is 45, The lateral area of this is 125. The volume of the smaller paint can is 54. Find the volume of the larger paint can. So the mistake a lot of you made in chapter 10 was you said, oh, 45 over 125 equals 54 over x, cross multiply, and I'm done. It's not that simple. We need to first find the similarity ratio. Right now we have the area ratio. So again, I highly recommend just setting up this chart every single time. And if you need to, you can even put the formulas. So this would be our area. So we have 45 over 125. Lateral area is still area. How do I find my similarity ratio? Use square root. Do we know the square root of 45? Do we know the square root of 125? No. So since these are not perfect squares, we want to reduce first. And you can reduce in your head, dividing by 5 in the top and the bottom. You'll get 9/25. But if the numbers get really large, which they may in the homework, you can use your calculator to reduce fractions. You just divide them. Divide the numbers. You get a decimal. If you have a graphing calculator, you press math, arrow fraction, which is the very first option. You hit enter 2 times, it gets you 9/25. On the simple calculators, there's an F to D button that you can change it back to a fraction on the decimal. So we do get 9/25. That's still under the area column. Now we can square root to get back to our similarity ratio, which is 3 to 5. Don't write a proportion yet. That was just step 1, find the similarity ratio. Now we want to find the new ratio. They want us to find the volume. So we now have to find the volume ratio, which would be 3 cubed over 5 cubed, which is 27 over 125. Now we can write a proportion. We have the volume ratio, 27 over 125. We can write our proportion, which is going to be your last step, not your first step. Now, they give us the volume of the smaller can is 54. Is that going to go in the numerator or the denominator? The numerator. You want the smaller to be in the same level of the fraction with the smaller number. And then you can just put a variable v, x, whatever in the denominator. Now we take the cross product. So 27 times x equals something big. Thank you. And then we undo multiplication with division. And we should get 250. Now look back at the question to know what type of units we're throwing on. This is the volume of the large can. Volume will be units cubed, so this will be centimeters cubed. So do we see how it's not as easy as just writing down the numbers and cross multiplying? You have to find the similarity ratio, find the ratio you want, and then write a proportion. Okay, let's try the next one. They give us the volumes, and they want us to find the surface areas. And I'm not going to draw these because we don't even know what they are, just as similar solids. And you don't have to draw them, it's kind of a waste of time. Similarity, area, volume. If you don't set up this chart, there's a good chance you're going to make a mistake, but I'm not going to require you to do it. But I did a ticket out in period 1, or period 2, and a bunch of them that didn't set up the chart got the problem wrong. So, take that for what you will. They give us volumes. 128 over 250, that's going to go in my volume column. Remember, this is a cubed over b cubed. How do I get back to my similarity ratio? How do I get back to a over b? Cube root it. You'll find out if you type it in, 128 and 250 are not perfect cubes, which means we should reduce the fraction first. So 128 divided by 250, math fraction, I'll get that this is really 64 over 125. So I want to go back to my a over b, And we said we're cube rooting. The cube root of 64 is just 4. And the cube root of 125 is 5. 5 times 5 times 5 is 125. They want us to find the surface area, so I need to find the area ratio now. Which means I have to square the top and square the bottom. So I'll get 16 over 25. Now I can use this area ratio to write my proportion. Because I have area and I'm setting it equal to area. So 16 over 25 equals something over something. They give us the surface area of the larger solid is 250. Will that go in the numerator or the denominator? The denominator. The bigger numbers down here. Our variable would go up here. Now some of you will notice that it's just 25 times 10 is 250, so 16 times 10 is 160. But if you don't, you just cross multiply like you normally would. And then double check our units. Surface area, so this will be squared. If you, on your test, do this, 128 over 250 equals x over 250. I will take off all the points, so it's 100% wrong. You cannot just write a proportion and solve. Area and volume are not equivalent ratios. All right, the last one talks about a pyramid paperweight, marble paperweight shaped like a pyramid. It weighs 0.15 pounds. How much does a similarly shaped marble paperweight weigh if each dimension is 3 times as large? So first of all, weight. Do you think weight would represent their ratio of sides, their area, or their volume? Volume, because weight would be how much is inside, and that would tell you how heavy it is. So weight is going to be using a volume ratio. Each dimension is 3 times as large. What does that tell me? Similarity, area, or volume? Tells you the relationships of the sides. So if one of them is, let's say, 1 inch, the other one is 3 times as large, that would be 3 inches. So the similarity ratio is 1 to 3. If I said it was 6 times as large, 1 to 6. 10 times as large, 1 10. And you could do 3 over 1. It doesn't matter which way you put it. But it should be a fraction. Now, we want to find the volume ratio. So I really don't need this area. I just need the volume ratio this time. So to get from similarity to volume, what do I do? Cube, which is 1/27. Now we can write our proportion. So 1 over 27 equals, and this weight was the smaller paper weight, so that goes in the numerator. X would go in our denominator. And we'll cross multiply and get 4.05 pounds. Okay, I do have a ticket out for you guys to do, and then you guys can work on the homework. The ticket out has 3 questions, very similar to the ones we just went over. I will warn you that the last one gets you a really big number that doesn't sound realistic, but it is. But some of you will think you got it wrong because it's large and it talks about weight. So you can work with a partner or in a group of 3 if you'd like. You just do one, put all of your names at the top. And when you're done, turn this in and you can pick up your homework, which is on my desk.